Welcome children. In the last session we have seen about the system of linear equations. Here in this session we are going to see how to say the system of linear equation is consistent or not. What do you mean by consistency? Consistency means having solution. That system may contain one solution or more than one solutions. So, we will be arriving while solving, if you arrive at a statement which is false, that is in between the process of solving, if we have a false statement, we can say that there is no solution. What do you mean by a false statement? In between, while solving the equations, we may have an equation like this, 0 equals 1 or 0 equals 7. So, this which is not true. So, if a false statement occurs in between, we will be stopping there itself and we will be saying that the system has no solution. And in one more case, if an identity is obtained like 0 is equal to 0, 0 is always equal to 0. So, this is an identity. If an identity occurs in between the process of solving, we will be stopping there and saying that the system has infinitely many solutions. And if you get the values, that is as proceeding, we will be getting values of x, y and z. Then we say that that system has unique solution. So, these are the nature of solutions in the 3 variable linear equations. Now, let us do some problems involving all these procedures. In this case, see the system of equations. We are going to name these equations as 1, 2 and 3. Now, see the third equation where it has no y coefficient. So, this is an equation in 2 variable. So, let us eliminate y from 1 and 2. So, let us take the equation 1 and equation 2 and add those two. So, x plus 2y minus z is equal to 6 and 3x minus 2y plus 5z is equal to minus 12. So, we are going to add these two, get minus 2x, here it is 0 plus 4z is equal to minus 6. So, adding we have got one equation. Let us name this equation as 4 and taking two, that is third equation and the fourth equation and eliminating, that is we are going to have, see x minus 2z is equal to 3 is our third equation. Here 2x, so minus 2x is there. So, we are going to multiply third equation by 2. So, it becomes 2x minus 4z is equal to 6. So, adding these two, we get minus 2x plus 2x as 0, 4z minus 4z as 0. So, 0 plus 0 is 0 and here plus 6 and minus 6 is 0. So, we have got an identity which is 0 equal to 0. So, this identity means we have to stop here and we have to say that this system has many solutions. So, this system of equations has infinitely many solutions is our answer. See these 3 equations, 2y plus z is equal to minus 3x plus 3. So, I have changed this as x, y and z one side and constant the other side. So, 3x plus 2y plus z is equal to 3 is the first equation and the next 2 equations are named as second and third. Now, we are going to eliminate, let us eliminate z because it has 1 or minus 1 as its coefficient. So, let us eliminate z from 1 and 2. So, let us take 1 and 2 now and 3x plus 2y plus z is equal to 3 is the first equation and minus x plus 3y minus z is equal to minus 4 is the second equation. So, adding we will be eliminating z. So, adding we will be getting 2x plus 5y is equal to minus 1. So, we can name this as our fourth equation. From second and third equation, we will be eliminating the same z. Adding these two, we get 2x plus 5y is equal to minus 4 minus 1 by 2, that is minus 9 by 2. So, look at these two equations, fourth and fifth equation. So, these two have x and y as variables. So, let us eliminate x or y. So, what can be eliminated? Y can be eliminated by subtracting. So, let us subtract fourth equation from the fifth one. So, 2x plus 5y is equal to minus 1 is to be subtracted. Subtraction is nothing but adding the additive inverse. So, add the additive inverse. 2x minus 2x is 0, 5y minus 5y is also 0. So, 0 plus 0 is 0, and here minus 9 by 2 plus 1 is minus 7 by 2. So, which is not a true statement. So, this is a false statement which says that this system is inconsistent, that is, it has no solution. So, there is no point where all the planes meet. So, this is about the nature of the solutions. Look at the sum. This system has 3 equations. We are going to derive the first, second equations from this equation. So, if you equate these two, you will be getting one equation, that is y plus z by 4 is equal to z plus x by 3. So, multiplying by 12 both sides, that is LCM of 4 and 3, we will be getting 3 into y plus z is equal to 4 into z plus x. So, multiplying 3y plus 3z equals 4z plus 4x. So, having x as positive, 4x minus 3y plus 4z minus 3z becomes plus z is equal to 0 is the first equation. So, for the second equation, we should take the first and the third part, that is y plus z by 4 is equal to x plus y by 2. You may take these two also and equate, get the second equation. So, I have taken these two now. See, 4 and 2. So, LCM is 4. So, this should be multiplied by 4 both sides. So, it is y plus z here and here 2 into x plus y. So, multiplying we get 2x plus 2y is equal to y plus z. Simplification becomes 2x plus y minus z is equal to 0 is the second equation. So, the originally given equation can be taken as the third equation, that is x plus y plus z is equal to 27 is our third one. See the first, second and third equation all have x, y and z. So, we may eliminate any variable. Now, it is easier to eliminate z from these. So, from 1 and 2 we may eliminate z by adding. So, 1 and 2, equation 1 and equation 2 are to be added. So, adding we get 6x minus 2y is equal to 0, and taking second and third equation and adding, we will be eliminating z again. So, 3x plus 2y is equal to 27 becomes the fifth equation. So, this is our fourth equation and this is our fifth one. So, solving these two, we will be getting the values of x and y. So, solving fourth and fifth one. So, if you add, y becomes cancelled. So, 6x plus 3x becomes 9x is equal to 27. So, x is equal to, yes, dividing both sides by 9, we get x is equal to 3. So, substituting x in fourth one, we get 6 into 3 minus 2y is equal to 0, which is 2y is equal to 18 or y is equal to 9. So, in the third equation, if you substitute x and y, we will be getting z. So, z here is got to be 15. So, in the sum, we have arrived at the values of x, y and z. So, which means nature of the solutions is unique. So, this system has only one solution. See, let us have some real life problems regarding this solving linear equations. See, in this sum, in our exercise, we have to find the ages of Vani, her father and her grandfather. Some statements are given in words. See, the first statement goes as the average age of those 3 people is equal to 53. 53 is their average age. Before entering into the sum, we are going to name the ages of Vani, her father and her grandfather as X, Y and Z. Then let us have the average as 53. And one more statement says that half of grandfather's age plus 1/3, that is 1/3 of her father's age plus 1/4 of her age equals 65. And the last statement says as before 4 years, that is 4 years ago, grandfather's age is 4 times Vani's age. So, keeping all these in mind, we are going to derive at the equations first and then we are going to solve them. So, first we are going to frame the equations. So, using the first statement, average of the ages is 53. What do you mean by average? Average is nothing but sum divided by number. So, sum of the ages. So, the ages are taken to be X, Y and Z. So, sum of the ages is X plus Y plus Z. Average means dividing this sum by number. So, how many people are taken? Yes, 3. So, dividing by 3 we get the average and it is given as 53. So, we can equate it to 53 and restating we may get the first equation, that is X plus Y plus Z is equal to, multiplying by 3 both sides we get 159 is the first equation. Look at the second statement which says half of grandfather's age. So, half of grandfather's age, here grandfather's age is Z. So, Z by 2 plus 1/3 of her father's age and Y by 3 plus 1/4 of her age, that is Vani's age. So, Vani's age is X. So, divided by 4, add up to give 65. So, is the second equation. We are going to rephrase it, that is taking LCM, multiplying by the LCM both sides, that is LCM is 12. So, multiply both sides by 12. So, it becomes 6Z plus 4Y plus 3X is equal to 12 into 65, 780 is our second equation. Coming to the third one, 4 years ago. So, 4 years ago the ages will be less, yes, 4 less than the present age. So, the grandfather's age, present age is Z, 4 years ago it would be Z minus 4 and it is 4 times, 4 into times means 4 multiplied by Vani's age. Vani's age at that particular time. So, before 4 years Vani's age would be X minus 4. So, we can simplify this as Z minus 4 is equal to 4X minus 16 and we can have Z is equal to 4X minus 16 plus 4, that is minus 12. So, we can take this as third equation and we can substitute the third equation in first and second to simplify and we are going to solve these two. Okay. First, let us substitute Z in 1 and in 2. Okay. Substitute Z in 1. So, Z can be taken as 4x minus 12. So, in the place of Z, we are going to substitute 4x minus 12 in the first equation. Okay. So, here simplifying we get 5x plus y is equal to 159 plus 12. So, 171. This may be taken as our fourth equation and substitute Z in second to get the fifth equation. So, 6 into Z is 4x minus 12 plus 4y plus 3x is equal to 780. So, multiply 24x minus 6 into 12 72 plus 4y plus 3x is equal to 780. So, two terms of x here are to be added. So, 27x plus 4y is equal to 780 plus 72. So, 852 is our fifth equation. So, see the fourth and fifth equation, we may have to eliminate y or x. Shall we eliminate y? That will be easier. So, multiplying by 4, that is multiplying the fourth equation by 4, we get 20x plus 4y is equal to 4, 4 7s are 28, 4 1s are 4 plus 2, 684. So, getting back to the fifth equation, 27x plus 4y is equal to 852. Subtracting, we may eliminate the y term. So, subtract minus 7x is equal to minus, so subtracting we get 12 minus 4 is 8 and 14 minus 8 is 6, 7 minus 6 is 1. So, minus 7x is equal to minus 168. So, x is equal to minus 168 divided by minus 7, that is, so minus negative symbol gets cancelled and 24 is our x. So, x is nothing but the age of Vani. So, using x we can find y in substituting in for the equation number 5 or 4. 4 is easier. So, substitute x in fourth equation. So, substituting x in fourth equation, we will be getting 5 into 24 plus y is equal to 171. So, 5 into 24 is 120. So, y is equal to 171 minus 120, which is 51. So, age of Vani's father, y is Vani's father's age is 51. So, using these two, we may have z, that is we may substitute x in the third equation, substitute x in third equation and get the value of z. So, z is equal to 4 into x is 24 minus 12. So, 4 into 24 is 96 minus 12 is 84. So, Vani's grandfather is 84 years old. So, these are the ages of all these 3 persons. Look at the sum. The sum of the digits of a 3-digit number is 11. If the digits are reversed, the new number is 46 more than 5 times the former number. If the 100th digit plus twice the 10th digit is equal to the units place, find the 3-digit number. See, first we are going to find the 3-digit number. Let us name the digits as x, y and z. So, let the digits be x, y, z. So, if x is hundreds place and y is tens place and z is units place, so we can have these 3 digits and the sum of the digits is 11. So, we have to derive, that is we have to frame equations using these statements. So, the sum of the digits, so x plus y plus z is 11 is taken as our first equation. So, next statement goes as if the digits are reversed, the new number is. So, what happens if the digits are reversed? First, what is the value of this particular number? If the number is stated as x, y and z in this order, we should not take it as algebraically, it is not a multiplication. How will you find the value of this number? That is, if you place x, y, z in the sequence, what is the value of this number? That is the value of the number. Value of the number means the place value of x is 100. So, 100 times x plus the place value of y is tens. So, 10 times y plus the value, that is place value of z is units. So, 1 z, that means z. So, we have got the value of this number and if the digits are reversed, what happens to the number? So, we are going to find the value of the number reversed, value of the reversed number. So, if the numbers, the digits are reversed, z, y and x are to be placed in the sequence. So, it becomes 100 z plus 10 y plus x as we reverse the digits. So, what happens to the statement? If the digits are reversed, the new number is, so this is our new number is 46 more than the 5 times the former number. So, the new number is this, that is 100 z plus 10 y plus x is, so while framing is to be represented as equals. The new number is 46 more than, 46 more, that means 46 plus. So, 46 is added more than 5 times, 5 times means 5 into 5 multiplied by the former number. Former number is 100x plus 10y plus z, the value of the original number. So, the statement goes as the new number is 46 more than 5 times the former number. So, we have to simplify this equation. So, as 46 plus we can multiply by 5 and get it as 500x plus 50y plus 5z is equal to 100z plus 10y plus x. On simplification, we get 500x minus x that side. So, 499x and 50y minus 10y which is 40y plus 5z minus 100z. So, minus 95z is equal to minus 46. This 46 comes as minus 46. This is our second equation. So, let us go to the third equation. If the hundredth digit is x here, okay. So, x plus tens digit, twice the tens digit is y, twice the tens digit means 2y is equal to the units place is z. So, this is our third equation. So, we have got 3 equations and we are going to simplify these 3 equations. So, all these 3 equations have x, y and z. So, we are going to eliminate any variable from one pair and then eliminate any variable from the other pair and proceed like the previous sums. See, we have seen all those 3 equations. We are going to solve those 3 equations now. So, the first equation goes as x plus y plus z is equal to 11 and the second equation is the larger one and the third equation is x plus 2y minus z is equal to 0. See, among these 3 coefficients, y has the least coefficient 40. So, we have to eliminate y from all those 3 equations. So, first let us take the first and the second equation. See, to eliminate y, we have to multiply the first equation by 40. So, multiply, but I am going to multiply by minus 40 because it makes easier. On addition, we will be eliminating y. So, multiply first equation by minus 40. So, minus 40x plus minus 40y plus minus 40z is equal to 40 into 11 negative. So, minus 440 and the second equation is taken as such. If you add these two, it becomes 459x minus 135z is equal to minus 486. Do not think these numbers are so large how to do, but it becomes so easier if you simplify. Okay. In the last step, you will be seeing that this larger sum becomes so smaller. See, I am going to take the first and the third equation now and eliminate the same variable y. Okay. So, to eliminate y, we need to multiply the first equation by 2. Here also we are going to multiply by minus 2. This becomes easier for you. So, minus 2x minus 2y minus 2z is equal to minus 22. So, adding the third equation with this, we will be eliminating y and we will be getting a smaller equation and name this equation as 5. and we have named the equation as fourth equation. So, look at this fourth equation. As it is so large, we can say that all these coefficients are divisible by 3. So, divide both sides by 3. So, on dividing, we have got 153x minus 45z is equal to minus 162. So, even though it is larger, it becomes easier to solve in the next step. See the next step, we are going to take this fourth equation and fifth equation. See, fourth equation has minus 45z and fifth equation has minus 3z. So, to make these two equal, we have to multiply the fifth equation by 15. So, multiply by 15. So, for our convenience, we are going to multiply by minus 15. So, this becomes minus of minus plus 15x plus 45z plus 330, and then add this with the fourth equation. So, fourth equation is here. So, if you add, z gets cancelled and this becomes 168x, which is equal to 168, which is very easy to solve, where you get x is equal to 1. So, having this x as 1, substitute in 5. Fifth equation is the easier one. So, substituting the value of x in the fifth equation, we get minus 1 minus 3z is equal to minus 22. So, add 1 both sides, we get minus 2z is equal to minus 21, which means we get minus 3z is equal to minus 21, which means z is equal to 7. So, we have z and x we have found. So, using those two, substitute in the first equation, get the value of y. So, y has got to be 3. Now, we have the values of x, y and z. What to find in the sum is to get the 3-digit number. So, we have taken the digits as x, y and z. So, we need to find the 3-digit number, which is x, y, z. That is, we are going to replace the values of x, y and z in this and get the number as 137, that is 137. You can verify by reversing this, you will be getting the reversed number. You can verify using the statement. See the sum, students. There are 12 pieces of 5, 10 and 20 rupee currencies whose total value is rupees 105. When first two sorts are interchanged in their numbers, its value will be increased by rupees 20. Find the number of currencies in each sort. See, there are 3 sorts of currencies whose total number is 12. So, there are 12 pieces, which means there are 12 currency notes. Let us name the currency notes, the number of currency notes as x, y and z respectively for 5, 10 and 20 rupee notes. That is, there are x 5 rupee notes, y 10 rupee notes, z 20 rupee notes. Their sum, the number becomes totally 12. So, the total number of currency notes is 12. So, we have to add these numbers x plus y plus z as 12. And the second statement says that their value, total value is 105. What do you mean by value? The number of notes into the currency value. So, there are x 5 rupee notes. So, the value of 5 rupee notes is 5x. For example, if there are 2 5 rupee notes, you will be saying that 2 5s are 10 rupees is there with me. So, 5 into 2. So, like that we are going to multiply the number of notes into its value. So, 5x. There are y 10 rupee notes. So, the value of 10 rupee notes totally 10y. There are z 20 rupee notes. So, the value of 20 rupee notes is 20z. So, in total the value is 105. So, add and get the value of 105 to get the second equation. So, the third equation says that if the first two sorts are interchanged in numbers, that means if there are, see, x 5 rupee notes are there, y 10 rupee notes are there. If you interchange, there will be x 10 rupee notes. So, x 10 rupee notes and y 5 rupee notes. So, if you interchange a number, the value increases by 20. So, the original value is 105. So, if you increase 20 rupees, the value is 125. So, the total value is 125. So, we have framed the equations. Using these equations, we are going to solve and find the values of x, y and z. So, see in all these equations, it is easier to eliminate z. So, because z has the same coefficient in second and third equations. So, we are going to eliminate z from the first and the second one. So, to get the coefficient same, we have to multiply the first equation by 20. So, multiply the first equation by 20. For my convenience, for our convenience, we are going to multiply by minus 20. So, by adding we will be cancelling. So, multiply by minus 20 both sides of the first equation. So, it becomes minus 20x plus minus 20y plus minus 20z is equal to minus 240. So, we can eliminate these two by adding minus 15x plus minus 10y, this becomes 0 is equal to, adding we get minus 135. So, we can name this as our fourth equation. So, we are going to take the second and third equation to make, see z are same here, the coefficients of z are same here. So, we can just subtract. So, subtracting we get minus 5x plus 5y is equal to minus 20. So, this is our fifth equation. Look at the fourth and the fifth equation. Here we have 15x and here we have 5x and here 10y and here 5y. So, which is easier to eliminate? Yes, eliminating y is easier. So, multiply this by 2 to get the same coefficient. So, multiply the fifth equation by 2 and get the answer as minus 10x plus 10y is equal to minus 40, and the fourth equation goes as, and we are going to add and eliminate y. So, we have minus 25x is equal to minus 175. That means, x is equal to, dividing both sides by minus 25, we get 7. So, substituting the value of x in the fifth equation, we are getting the value of y. Okay. So, try this and substitute the values of x and y in the first equation, get the value of z. This means, the number of 5 rupee notes is 7, number of 10 rupee notes is 3 and the number of 20 rupee notes is 2. Can you understand all these sums? You can have some more problems related to real life using all these 3 linear equations and try to solve on your own. Try all these models and let us meet in the next session. Thank you, children.